So I want to start talking about something called irrational numbers. But before I talk about a rational number, I want to go all the way back to something called the real number system. And you can see the real numbers are all numbers on a number line. Everything, anything that you can think of that could possibly go on a number line, it'll go there, including positives and negative integers. Okay, positive, negatives. Integers and rational numbers. What's a rational number? Those are fractions, those are decimals, those are repeating decimals, and so on. All the square roots, cubes, cube roots, pies, everything else, they all fit on this number line. So guess what? They are all part of the real number system. Now, let me show you something that's really, really easy for you to kind of understand. I'm going to show you how this works, okay? What is a real number? Because I could talk about number lines all I want, but unless I actually show you where they come from, you might not get a handle on it too well. So, when you're doing number systems, and I've got all the number systems, you can see them all sitting over here on the side. I'm going to pull them in as I need them. But I want to talk about the original number system, the natural number system, which we call the counting number system. Counting numbers just means, well, think about it. When you start counting that, counting things like money, counting apples from an orchard or whatever, I could just start counting and say, we'll start with 1, we go to 2, we go to 3, we go to 4, and we go onwards and onwards and onwards. These are called the natural number system, and they actually have a symbol called n here. Now, let me bring in the next system that comes in. The next system that comes in is the whole number system. And I'm just going to try to pick it up here. This is the whole number system. Now, what's cool about the whole number system? Well, guess what? It includes all of the natural numbers. So in everything, 1, 2, 3, and 4, but it also includes a 0. So here are all the natural numbers, 1, 2, 3, and 4, and so on, but you need to include a 0. That's it. That's the whole number system. And that's why I always say, when you're thinking a whole number system, think of it as a whole, and that 0 looks an awful lot like a hole. See what I mean? Okay, what's the symbol for that? W. Yes, represents the whole number system. The next number system, okay? Think of this one. Here we go. What's missing? What do we need? We need positive and negative numbers. Why do we need positive and negative numbers? Oh, things like temperature. But actually, traditionally, positive and negatives came from, guess what? Borrowing money. So positive negatives. What is in a positive negative system? Well, guess what? All the natural numbers are there. All of the whole numbers are there. But now we also need the negatives. So I can start this and say, okay, there's my natural numbers, 1, 2, and 3. There's my whole number, 0. But now I've got my negative numbers, -1, -2, and -3. One of the things that you'll notice, and people commonly make this mistake, is that they think that you can put fractions into this. No, no fractions, no decimals, not in the integers. That's not, we're not there yet. Okay, so think about it. We have negatives and positives in this situation. We call the integers, yep, I. Yep, for integers. Boy, that's simple. Now, think about it. What's missing? Well, I gave you a hint. No fractions or decimals. Well, that comes our next system, which includes all the naturals, all the wholes, all of the integers, but now we have to include terminating decimals, things like, oh, I don't know, 0.5, that stops. It doesn't go on forever and ever. It stops. Fractions like, okay, 3/4. Repeating decimal, like when you get into a calculator and you'll notice it goes 0.333 and onwards, and we put a little line, that is actually considered to be a rational number. Now, again, what's missing after that? Well, think about it. There's a lot of numbers that are still missing. We didn't address something like pi. Pi, which is a running on number that has no pattern to it whatsoever at all. And there's another type of number missing. Anything with a square root. Look how specific this is. Okay? Look how specific this is. Irrationals are the group that's missing. And if you think about what an irrational is it's a number that has no pattern to it, like pi. 3.14, blah, 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 blah. It never ends. No pattern, never ending. So look at something like, okay, pi is probably the best example of it. Another one, square root of 2. Another one, square root of 5. These are all possible numbers that when you put them into your calculator, there's no way of writing this as a fraction. Why? Because the numbers never end and they keep on going and going and going and going and going. So we call those irrational. Now wait a second. What was the symbol for these rational guys then? You're probably thinking, well, rational guys should be called R's. Reals are called R's. Rationals are actually called Q's. And the Q stands for quotient. Why? Because look at this fraction here. You see the line? The line means to divide, and that's what quotient actually means. So think about this. Think about something like the irrationals that you can't put as a fraction. So in other words, you can't divide. So we call them Q because they sound like rational and irrational, but we put a bar on top of it saying, you can't divide it. You can't put it as a fraction. So that's what that means. Now, what is this whole group? Now look at this whole group. Everything from irrationals to naturals to wholes to integers to rational numbers. Yep, you guessed it. They are all part of this ginormous group we call the real number system. So the real number system includes all of the numbers, the irrational guys, the natural guys, the whole guys, the integers, the rational numbers. They include everybody.